So here we have the first test on the AC solid state relay. What you see on the screen on the scope is a 120 hertz AC wave, or 120 volt 60 hertz AC wave. Scope is set up to show both channel A and B. So channel B, I think it is on the input side of the solid state relay, and channel A is on the output stage. So right now you're seeing an input with no output. I have a lamp here as a load. I'm just going to turn the load on, and you see that there is a sine wave on the output now. I've got them set at different scales so that you can see that they're both on. But the signal passes through the solid state relay just nicely, and we are the light you probably saw come on the side is that light, which completely washes out the picture. And I will just grab the meter and show you the current. Sorry for the jittery camera work. So if we shut it off, we see the current there go to 0.2 amps. We're going to turn it back on, and it goes up to 1.5 amps. We're going to change the load and switch. So that's off. One bulb, it's at 0.7. The second bulb, or an alternate bulb, it's 0.8. And then we have both, and it's 1.5, which still confuses me a little bit. Back to the scope. Oh, that looks kind of weird on the screen. Anyway, we're at off, so the signal looks good. We have one bulb, we have the other bulb, looks the same, and we have both bulbs, and again it looks the same, except for the flickering of the screen and the flickering of the camera aren't quite in sync. Next test, here we have the Arduino Uno. We have 5 volts and ground connected to the solid state relay, and I'm just going to take the Arduino and plug it into my laptop, see whether anything blows up. It should turn on the load, and it should, yep, it turned on the load. And over here you see a little red light showing that the solid state relay is on. So I'll disconnect my laptop, and that's it for this test. The 3.3 volt output, we're going to see whether the solid state relay turns on or not. Nope, put it on the laptop. And apparently it does. So 3.3 volts is enough to turn on the solid state relay. The specs are 3 to 32 volts, so it should have worked, but it's nice to know that it does. And here we have an Arduino switch which turns on the output for 5 milliseconds, turns it off for 15, and then repeats the cycle. And that's pretty much all it does. And you see that you get approximately 3 half waves on the positive, a little bit of a gap, 3 half waves on the negative, and then it repeats. It's kind of hard to see, but anyway, that's what is happening on the screen. This is what's happening to the bulbs. Where the hell did they go? And I don't really expect the incandescent bulbs to last very well doing this. But the amps, the average amps that the meter is measuring is approximately correct. It's still about 1.1, just under 1.2 amps. So, January 7th, here we are with a demo. So we still have our solid state relay. You can see the red light flickering. It's going on about 4 hertz. But it's, as you can see on the scope, the trigger is sliding with respect to the AC wave, so the output from the LED up here is nowhere near consistent at 4 hertz. And I tried it with 1 millisecond less, and the trigger signal goes this way with respect to the AC wave, so it's not helping a whole lot. I can do this, and you can see the trigger just sliding across like crazy. So hopefully you can see that a little bit better. Anyway, detecting zero cross is the way that we're going to have to go. So this sketch, useless as it is, will be stored under January 7th timing, and that's what we're doing, is just doing a straight timer with a delay instruction, and the code will be there. This is what it does when you connect it up. We've got the solid state relay hooked up, positive and negative, to output 13 on the Arduino, and it's just a 5-volt output going through a couple of 10K resistors, mostly because I needed some way to connect the wires up that was solid, that wouldn't fall off. Right now what we're monitoring is on the scope is the AC input waveform and the trigger, and what we're going to show here is the output waveform, which it shows that there's a little bit of leakage, and it's not really very good. Give me a second here. I thought that this was going to be a little bit better, but it's just showing the occasional twitch where the solid state relay is fired, so we really can't see a whole lot on this, so I guess I'll just stop that. So this little motor is rated at 2.5 amps at 120. It drives this belt and then drives the drill press. So that's what I'm going to be using for my induction motor for the first test, see whether the solid state relay will actually survive. What I'm doing here is the same thing that I was doing before. I have the input and the output AC waveforms, and they are on the same scale. I could superimpose them, but then you can't really tell which one's which. So the top one I'll take off here. Yeah, that's the top one. So top one is the source. The bottom one is the load, and I'm just going to turn the drill press on, and we'll see whether or not our solid state relay survives. Okay, I can hear a noise where it's not really doing much now. Right now we're just turning on either the positive wave or the negative wave. We're not turning both on, which is I guess why I don't have enough torque to actually turn it. So the current is still 0.2 when it's there's no current at all. So we're going from 0.3 to 1.6 and then down to 0.2. So the current isn't consistent, and it's definitely not enough to do any torque on the motor. That's what's happening with the motor. It's actually just twitching forward and going back. So it's not getting enough torque to stay in the forward position, and then it goes back. So I'm not sure what exactly is going on, but I'm gonna send it a few more pulses and see if it at least rotates. So now doubling the number of pulses, so 2 positives and then 2 negatives and then 2 positives, 2 negatives. We're again going down to 0 current, but we're going up as high as 2 amps. So I think I can pretty safely add another pulse. And the code is still just timing based, and it's not going to work. I've got to build the zero cross detector to get any kind of performance of it.